So you have the angle of friction, the angle between the resultant of F and N. In the purple, that's the angle of friction. And there's two facts to know. Tangent of phi s equals mu s, tangent of phi k equals mu k. Okay? And then there's the objects on an incline. There's two angles. One is the angle of friction. One is the angle of the incline. And there's some stuff to know about. And then I give you dry versus lubricated surfaces. And of course, my favorite, which, if this is my favorite, what do you think? Is it going to be on the quiz, on the test?
Probably.
Alright. This is the first time that we actually relax the condition of, hey, no friction. Back in chapter 3 when we did police TT. Now it's T1, T2 because now we're involving friction into the problem. And the relationship between T1 and T2 is the belt friction equation. T2 equals T1 e to the mu beta. Beta is in radians and beta is the amount of cable wrapped around something. So this would be the amount of wrap, which is 180 degrees, which is high radians and so forth and so on. Got it? Then we talked about when you solve problems. I personally do this. I recommend you do too, but you don't have to do whatever I say. It's fine. I'm telling you what I do because it kind of gets my mind in the proper direction for solving the problem. First thing I look at is, hey, what's the model? Because this is the first chapter that they incorporate particle and one chapter. Chapter 3 was all particle equilibrium. Chapter 5 was all rigid body equilibrium. Now we're putting particles and rigid bodies together. And I usually decide, I write model and I decide, is it a particle? What's that doing for me? Well, what it's doing for me is it's setting in my mind some force of the x equals 0, some force of the y equals 0. When I say rigid body, it's setting in my mind three equations, x, y, and a moment equal to 0. Okay? And then if I read the question, I can then decide, is it type 1, type 2, or type 3? Type 2 is the easiest because somewhere in the statement, it's saying, hey, find me this without upsetting equilibrium. Or when this thing is on the verge of moving. Either way, you're at the peak point of the graph. Well, if you're at the peak point of the graph, then this must be true. So in addition to the equilibrium equations, I'm throwing in F equals mu static times N, if it's a type 2 problem. And then if there's belt friction, well, I throw in the T2, T1, e to the mu beta into it too. Okay? Type 3 is the same thing. It's on the verge. Unfortunately, it's on the verge of what? Slipping? Or is it potentially tipping? So, all type 3s must be rigid body. And you must check whether the thing is slipping or tipping over. And then type 1, it says nothing. You know absolutely nothing. What you do is you assume it is in equilibrium, and you go in there and check. Notice I write FCAL, because if it's a type 1, you don't automatically write mu stat again. You let the friction force be a calculation. Then you can check your assumption by saying, is FCL less than or equal to mu static times N? If it is, then your assumption is correct. Okay? You with me? Questions? All right, let's get to problems. I'm going to skip around. I'm going to start with this one first on page 188. I'm going to get to all of them, but I'm going to skip around just so I can cover things that I think are more important than other things. Let's see that. So, the first thing we're going to do, forget the words. I don't give a shit about the words right now. Model. What model is it? Well, how do I decide the model? Well, the model is either particle or rigid body. How do I decide whether it's a particle or whether it's a rigid body? Well, if it's a rigid body, that means I can have moments. In order for me to have moments, I have to have distances. I can't do a moment without a force and a distance. So once I see 6, 3, whatever dimensions, automatically my mind says rigid body. Now, why do I say this or write it out? Because now I know I have 3 equations. Some forces x equals 0, some forces y equals 0, and some moments equal 0. So I'm kind of trying to solve the problem without writing a single equation yet. I'm putting in my mind what I need. I need these 3 equations. Now, I can't answer the type until I read the question. So it says, determine the largest force P that may be applied as shown to the block. Oh, here comes the key phrase. Without causing the block to move. Clearly, it is not a type 1. Because if it's a type 1, it would never have said that. So the process of elimination says it's either type 2 or type 3. Type 2 or type 3. That's it. That's all it can be at this time. Right? Now, when I look at this problem, could I put a force that causes this thing to just slide across the table or the floor? Yes. Could I apply a force such that it tips over? Yes. What type is it? Type 3. The clue is you have dimensions on it, more likely it's going to be a type 3. Well, if it's a type 3, I have to just look and investigate, is it tipping or is it slipping? Is it on the verge of slipping or is it on the verge of tipping? So I got to do 2 problems in one, is what I'm saying to you. So I got to draw a free body diagram of it showing as tipping over, and I got to draw a free body diagram of it showing as slipping. You with? Who's not with? So I'm going to draw a free body diagram, in quotes, tip. Because it's really on the verge of tipping. It's not really tipping. It's on the verge of tipping. So here is my free body diagram. Here's the block. Here's the load P. Here's the G of 300. The weight is at G, center of gravity. Here is my normal force. Here is my friction force. And I'm going to call that point C. If it is tipping, this is the tipping point where it tips about. So I put everything at that point. And now all I have to do is say, hey, let's do a sum moments about C equals 0. Let's take clockwise positive. That's going to be P times 6 minus 300 times 1.5 equals 0. P for tip is equal to 75 pounds. So what will cause it to be on the verge of tipping over is if I apply a load of 75 pounds to it. Now you can't say that's the largest that you can apply because I haven't checked slipping. I could slip before I tip. I got to check that. So I'm going to check that. Free body diagram. We're going to say slip. Here is the slip condition. We're going to apply a load P. Here's the center line. Here's G, where I'm going to apply the 300 pounds.
And now when I put my normal and my friction force, I'm going to put my normal a distance x away from the center line. And my friction force sits right here, but my friction force is mu static times n. Now you say, well, why the hell did you put n, a distance x from the center line? How many equations do I have? 3. If I were to write the moment equation and solve for x, it would tell me whether this is tipping or slipping. Because the distance from, say, this 0 to here is 1.5. If I wrote the moment equation and solved for x, and x happened to be something like 1.55, is that physically possible? It's tipping. So by putting that x, that normal force, an x distance away from the center line, I could write a moment equation and calculate x. And that x will tell me if it's slipping or tipping if I wanted to. That's why you put the normal force a distance x away from the center line. Okay. That said, I always start with the y because I usually need the normal force. So some force in the y, n minus 300 equals 0, n equals 300. Fantastic. And I know the friction force is equal to mu static times n. Well, that's 0.2 times 300, which is 60. And now some forces in the x equal 0 positive to the right. P minus 60, the friction force, equals 0. So P for slip is equal to 60. So what controls what happens? Well, slipping does. Because you're going to reach 60 way before you reach 75. So slip controls, and so P max is 60 without upsetting equilibrium or without the block moving. So notice, if I don't check slip and tip, I don't know which one's really occurring first. So I see a lot of problems. I give a problem like this on a quiz or a test, and people just do this and give me P equals 60. They never look at the tip. And sometimes it's tipping before slipping. Sometimes this value might be 50. Well, 50 is going to occur way before 60, so tipping controls. So when you only do one, or this one, or that one, you don't get the full picture. So when you have a type 3, you have to investigate all 3. Now remember, there is one equation still left over here because it's a rigid body. 1, 2, and what's the other one? The moment. If I calculate the moment, do a moment equation, and solve for x, it's going to tell me that x is way less than 1.5. That way I know for a fact it is slipping, not tipping. Questions? Thoughts, comments, ideas, anything about anybody on this one? Yeah?
So if you figure out that, slipping occurs before tipping, you use that small for
No. I'm done. I don't have to solve for distance. This, by doing both, you've eliminated that moment equation. Yeah?
In what case you have to find x?
You don't. Not really. Any questions? All right, moving on. I'm skipping, like I told you, I'm moving to different parts. Page 192 is already pre-worked out for you. It kind of shows you what's happening. So in this one, determine the P needed to raise and lower 2,000 pound weight. This is with belt friction. So I'm going to use the bulk friction equation. Notice P is 7,022, P is 569 to lower. And you can read this on your own. You know it is bulk friction equation. All right? So this one is to raise, this one is to lower. So if I'm raising, right? If I'm raising this will be T2, this will be T1. If I'm lowering, this will be T2, this will be T1. Because remember, T2 is in the direction of motion or impending motion. T1 opposes. All right? Turn the page. And the reason I'm skipping is because I really want to get to the bulk friction type problems. Because I know for a fact you're going to get a bulk friction problem. So let me cover it way ahead of time so that we're good. Forget the words. Somebody tell me what's the model. What's the model? For part A, what's the model? Particle. Do you see freaking dimensions on it? That's a particle. Two equations I get to play with. Some force X, some force Y. What about B? Still a particle. There's no size, no shape, no nothing. Two equations I get to play with. Now I got to decide type. Well, I can't decide type without reading the question. So right away I'm going to write model particle. That automatically says some forces X equals 0, some forces Y. That's why I write this, so that in my mind I'm already thinking of what are the equations I need to use to solve this problem. Bang, bang, bang. Now type. Like I said, I can't decide type until I read the question. It says block A weighs 200 pounds, so my suggestion would be put the 200 in here. Just like that. Coefficient between A and the horizontal surface, U of 0.4. Between the cable and the fixed drum, U is 0.5. So right away, alert goes up in my mind and says, ooh, we got bulk friction in this problem. T2 equals T1 e to the mu beta. So right away, I'm going to say, plus, I have this equation to contend with. Right? Then it says, what is the largest weight B may have and yet not move? There's the key word. And yet not move. What type is it? It is 2. Can it be 3? No, because 3 always has to be a what? Rigid body. It can be type 3. And it clearly says, yet not moved. If it was a type 1, you would see those words in there. So this is a type 2. Well, once I say type 2, I'm going to add F equals mu static times N. Listen, all my equations are sitting in front of me. They're all there. Who are you? I was going to say, because I don't remember you in my class. Who is he? A spy. He's your boyfriend. Oh, I'm sorry. So I'm anticipating this being T2, this being T1. Would you agree? So this is T2. And I'm going to write some forces in the Y equals 0, positive, doesn't matter when you go upward or downward, it's immaterial. Positive upward, T2 minus WB equals 0, or T2 equals WB. By the way, how many are going to dynamics with me in the summer? T does not equal W in dynamics. Everything is in motion. F equals MA now, not 0. Okay? It's the one thing I've been teaching dynamics for 30 years. 31. There hasn't been a single semester that somebody in that class has not said T equals W. I just finished grading test number 2 for dynamics. 12 people said T equals W. 12. Even though in class I said, T does not equal W. Nope. They didn't listen. Okay. I just take off points. All right. Here. I have weight downward, which in this case is 200 pounds. I have a normal force. I have a friction force, which I know is 0.4 times N. And this is T1 at an angle of 30 degrees, because that angle is 30, because this is an alternate interior angle. Now, notice I didn't put N a distance x away. It's not a rigid body. Right? Oh, my man's strolling in already. Nice of you to join us today. First, positive upward. Should I say N equals W? N equals W. True or false? Why? Yeah, because I have a component of tension in the Y. That is a very common mistake students make. They look and say, oh, N equals W. Not always. So be careful. I truly try to point out the errors I see over and over and over. That's one of them. Just like in the centroid area, I see always a negative sign error. So I'm pointing them out. So this is N minus 200 plus T1 sine 30 equals 0. Or N is equal to 200 minus 0.5 T1. Sine 30 is a half. That's equation 1, that's equation 2. Next, some forces in the x equals 0, positive to the right. Well, there's only 2, that's T and the F, so that's T1 cosine 30 minus 0.4 N equals 0. So that's 0.866 T1 minus 0.4 N equals 0. That's equation 3. If I now take this, dump it in here, notice I'll have one equation with one unknown T1. T1 comes out 75.046. Now, if we were in chapter 3, my answer would be W equals 75.046. Because T on the left must equal T on the right against the pulley. But that's not the case here. I need to go through the belt friction. So now I come in and say T2 equals T1 e to the mu beta. Well, that's T2 is equal to 75.046 e to the 0.5 times, I need the beta. I need the beta. What's the beta? What is my beta? Well, let me walk you through beta. So I'm going to try to blow it up a little bit for you. So here's my beta. There's the drum. I know this is sitting right here. That's 1. And I know that's the other cable tension. I know this is 30 degrees. So far, so good? Draw perpendicular to this. Draw perpendicular to this. Agreed? This angle will be 60. That means that angle is 60. That means this angle is 60, alternate interior angles. That means if I draw that's a 90 there, this angle has to be 30 in order to sum to 90. So what you're telling me is this arc is 30 degrees, this arc is 90 degrees. So beta has to be 30 plus the 90, which is 120. So beta is 2 pi over 3. Everybody see that? Take a good look-see. I'm going to repeat it just for the hell of it. So here it is repeated so everybody can see what I did. I drew a line perpendicular to this tension. I drew a line perpendicular to this tension. This angle here was 30, that was in the statement of the problem. Since this is 90 degrees, that has to be 60. These are vertical angles. Vertical angles are congruent from geometry. That has to be 60, which means that's 60 by alter interior angles. Now, if I draw a perpendicular here, that's 90. This angle in here has to be 60 minus 90, which means that angle is 30 degrees. That's how I got it. Any questions? Now it's a simple matter of saying, okay, T2 is equal to 75.046 e to the 0.4 times 2 pi over 3. T2 is equal to 213.86 pounds. What? Is it 0.5? Sorry. 0.5. Notice, please notice, it was 75 when I had no friction. This is almost 3 times as much, not quite 3, but almost 3 times as much at 213.86, 214. So in this case, is friction beneficial to you? Absolutely it's beneficial. It's allowing you to carry more load. That's huge. Back in chapter 3, we would have said that's 75. You see how piss poor that assumption was. Because in the real world, there is friction in the pulley system. That's a good thing, because now I can carry way more load. Any questions on what I just did? By the way, the previous problem plus this one were both old test questions. Now, if I wanted to go back to the other one, there was no belt friction in here. That's okay. I can simply go, now I got belt friction. Instead of find P, tell me W, this W, let's call it WB. What's the largest value WB can have without causing movement? Again, I have to check slipping, I have to check tipping, but I've incorporated now T2 equals T1 e to the mu beta in the problem. So it's not hard to take a simple problem and just add belt friction to it. And sometimes that's all I do. I go into the textbook, I look and like, yeah, no, I don't like this. Oh, I like this, I'm just going to add belt friction to it. Done. I have a problem for the test. Yeah?
So what determines which one's T1 and T2?
We already decided that. Did you not pay attention when we did T2, T1, E? Come on now. How did we decide that? It says it clearly right here. T2. Tension acting in the direction of motion or impending motion.
One BB going up.
I'm assuming it's going down. The only way it's going up is if that block A was moving that way. Then it would be moving up. But there's nothing that says it's moving that way. All right. Everybody get it? Let's do this one. Another old test question. So you're not only getting test questions in the testing manual, I'm giving you test questions in the pro copy booklet. Okay, so, again, I don't care about the words. Tell me the model for A. Rigid body, 3 equations of equilibrium. What's the model for B? Particle. So right away I can say model A, rigid body, B, particle. Oh, so you can combine a rigid body with a particle, bro? Absolutely. Why can't you? Remember, this is the first chapter we can combine both models together into one problem. Perfect. Now, this sucker is a rigid body. What do you think the type is? Correct. Watch. Block A is mass of 100 kilograms connected to block B by an inextensible cable. Nice 50-cent word that says, it don't stretch. Do cables stretch? Yes. Can I have stretch in this class? No. That means I would have a deformable body. I can't do that yet. That's why you're going on to the next class, Mechanics of Solids, EML 3500, or Mechanics of Materials, EGN 3331 if you're a civil. It's that simple. I cannot have things stretching or compressing or changing shapes or anything in this class. Okay. Type. We're finishing what it says. The cable passed over 2 drums C and D if the coefficient of static friction is 0.3 between all contacting surfaces. So this is 0.3, that's 0.3, that's 0.3. Now, I did this, I probably wouldn't do this again. I would probably give 3 different views. 0.3, 0.4, 0.5. Why? Because I'm going to check to see if you're paying attention to detail. Notice on the last problem I put mu 0.4. Was I paying attention to details there? No. I should have said 0.5 and somebody corrected me. It's exactly why I wouldn't give you the same mu. I did in this case, but I normally would not. I'd give you 3 different views and you can probably screw it up from there. Okay? All right. Free body diagram B. WB, which, I don't know, it's just WB. Right? And if I call this, for right now, I call this P. Some forces in the Y equals 0. Positive upwards, that's P minus WB equals 0. So the cable tension is WB. Notice T equals W in statics, not in dynamics. Although I will tell you, I did have T equal W, and it was equal to W. Why? Because the acceleration was 0. I forced the acceleration to be 0, which made T equal W. And I had to go, I knew it was TW, but you told me it wasn't going to be TW, so I erased it and changed it. I'm like, yeah, but the acceleration was 0. I should have told you T equals W. Okay? All right. Type. We said it was type 3. So I need to look at free body diagram, slip, and I need to do free body diagram, tip. All right, let's do tip first. Here's the tip. I'm going to tip on this point. I'm going to call this P because there's C and D and all that stuff. This is my, for right now, I'm going to call this P1. My normal force, my friction force, and here's my weight downward at the center, G, which in this case is 100, right? No, what is it? 100 times 9.81. W is the force unit, which is mass times G, so that's 100 times 9.81. That's going to be 981 newtons. This sucker is at an angle of 30. So now I'm going to do a quick moment. Some moments about P equals 0. And I'm going to take counterclockwise positive. That's 1 times 9.981. Because the center line is at a distance of 1 from P. And then minus T cosine 30 times its distance, which is this length here, which is 2.8. That's got to equal 0. So this is not PT, this is P1. So P1 is equal to 404.702. So the yank on that cable needs to be 404.702 to cause it to tip. You with? That's to cause the tip. Move what down? There you go. So I took a moment here. Remember, this guy over here has 2 components. One in the X, that's P1X, and there's one in the Y. This guy's going through P, creates no moment. So the only thing creating moment would be P cosine 30, that's the X component, along with the 981. Now, what about if it slips? So here we go. So this is P slip. This is P tip. I still have weight here of 981. Here's the center line. Now I'm going to draw N this way with a distance X. And since it's slipping, this is F is equal to mu static times N, which is 0.3 N. This angle is still 30. I'm going to do the Y's first. Some forces in the Y equals 0, positive up, because I want that normal force. N minus P slip sine 30 minus 981 equals 0. So N is equal to 981 plus 0.5 P slip. Do a sum forces in the X equals 0, positive to the right. That's going to be T cosine 30 minus 0.3 times N equals 0, or 0.866. It should be P slip. I keep forgetting. P slip is minus 0.3 N equals 0. Now, take this N and dump it into here. Notice you'll get one equation with one unknown, P slip. Because this will be 0.3 times 981 plus 0.5 P slip. You'll have P slip, in which case I will solve for P slipping. That P happens to be 411.034. That's newtons. So, what controls tip or slip? Tip, because you're going to get to 404 way before you get to 411. Not way, but you're going to get to 404 before you get to 411, which means it's going to tip over before it starts to slide. So now, I have the force coming into this pulley, and I know now this is 404.702. Now I got to do belt friction at C, and I got to do belt friction at D. I got to do 2 belt friction, not 1, 2. So here we go. I'm going to blow it up again. So I know this is going to be TCD. In other words, this cable going from C to D is what I'm going to calculate, right? TCD is equal to 404.702 e to the, what's the mu? Well, it's all 0.3 times the beta. Oh shit, I need the beta. Well, what the hell is the beta? Again, let's talk about beta. Here's this. That's the TCD. And we know that angle is 35 degrees. Here is the other cable, which is 404.702. Draw perpendicular to it. Draw perpendicular to it. You get that. Yes? Now, this right here is 35. Could I what? Okay, you got it. So if that's 35, what is this angle here? The fuck you can't now. What is that angle? If that's 35, well, okay. What's this angle here? 35, because vertical angles are congruent. What's that angle? 90 minus 35, which is 55. Well, if that's 55, then if I draw a horizontal line here, if that's 55, that's going to be 55, which means if I cut this here, this is 35. Agreed? Alternate, so there's a horizontal line here, there's a horizontal line there. That's 55, that's 55 because alternate interior angles. If I draw a horizontal line, a vertical line where this is perpendicular here, that's going to make this 35 because I got a total here of 90. Agreed? Do the same thing over here. Well, this angle here was 30. Okay. If that's 30, which means that is 60. Which means that's 60, which means that's 30. So what's the total angle here? 30 plus the 35, which is 65 degrees, which is 1.134 radians. Remember, pi radians equals 180 degrees. So x must equal to 65. Solve for x. Oh, shit.
Is it always the 2 equal minus
Not always, but a good chunk of the time it is. But I can make up a problem where it's not. That's why I'm going to painstakingly show you how I get these angles. Okay? So now this is 1.134. TCD is, what is it? 568.698. Now that is the cable that's going to drum D. Yes? You with me? So now I have this scenario. I have a cable that's going to block B. I have a cable over here that's coming, that is TCD. Draw perpendicular to it. That's 90 degrees. If you do the work, you'll see that that is 35 degrees. So beta is 90 plus 35, which is 125. So beta is 2.182 radians. And now I can say T2, which is WB, is equal to 568.698 e to the 0.3 times 2.182. WB is equal to 1094.386 newtons. And if you give me that answer, I take off points. What? Why? Why are you being so mean to me? What did I ask you for? Did I ask you for a weight or did I ask you for a mass? How do you get mass? Yeah, W equals mg. Mass is W over G. So what you're telling me by giving me that answer is, I don't know if I can tell the difference between weight and mass. Well, that's not true because almost the first, at least the second day of class, we went over what the difference between mass and weight was. You had a table in the first 7, 8 pages of the pro copy book that told you the difference between mass and weight. Yes? So my real answer is M is equal to 1094.386 divided by 9.81, which gives me 111.56 kilograms. That's the answer I'm looking for, not 1094. Yes? Who's not with me? What? What was the whole point of what? Because that's a way of finding out whether it tips or slips. If I solve for x, and x is between 0 and 1, because the whole thing is 2. So from the halfway point to the edge is 1. If I get something less than 1, then it is slipping. If I get something greater than 1, it's tipping. So if I were to do a moment equation, remember, over here I did 1, 2, there's still a third equation, the moment equation. So if I look at the moment equation, this is what my moment equation would look like. Some moments about g equals 0, say take clockwise positive, I have minus t cosine 30 times 1.4 minus t sine 30 times 1 plus the normal force times x minus 0.3 times the normal force times 1.4 equals 0. Well, you know what the normal force is. Normal force is 1186.517. Dump it in here. Notice you can solve for x. If you solve for x, you're going to get x equal to 1.013. Well, that's greater than 1. It tips. It tips. I got to get something either 1 or less. I got something greater than 1. It's tipping. That's how you use x to determine if you're tipping. And I already decided it was tipping because I solved for the force to tip and I solved for the force to slip. This would have to be lower than that. I know it's tipping before it slips. But this is another way of determining whether it really is tipping or not by solving for x. What are you looking at your phone for? Are you bored with me? Then why are you looking at your phone? He's your boyfriend, he's texting. What does he want? I'm going to punish you with more frames, and there's going to be a centroid problem. And it's going to kick your ass. Yeah. Yeah, I expect you to fuck it up.
Is it true or false?
No true false. The frame is good enough to fuck you over. So, I mean, no, the frame is actually pretty easy. No, it's pretty simple. No, it's a simple frame. It's a simple frame. No, it's only got one load. That's it. One load. That's it. Yes, my dear. Are you what? As long as you bring a stapler to staple, then you can staple it. So So if you want to bring your table to put the centroid in there, that's fine. I just drew a table on the sheet and that was it. Huh? You don't need it. Do you know the area of a triangle? You know the area of a circle? You know the area of a rectangle? Area of a square? That's it. You don't need anything else. Nope. Nope. Greatest of gyration would be in the area moment of inertia problem. This is only a centroid problem. What? Huh? What table? Now, you don't need it. And you can draw the table for the centroid area, x bar, a, etc. But just bring a ruler and draw a table. Other questions? Now I'm going to go over the frame problem you had on the last quiz, so you don't make the same mistakes on the new quiz that I'm giving tomorrow. Now I'm going to probably finish the problems in the Pro Copy booklet. So I'm going to do, let's see, I'm going to do 1, 2, page 186, 187, and 190 for sure tomorrow. And then whatever happens next week will all be help session problems. Okay?